So it's my pleasure today to introduce Dr. Gabriel Gasque, who is an advocate of open science, experimental reproducibility, and integrity in science. He's an expert in disseminating science, publication, communication, with more than 10 years of experience in the field. He got his PhD in biochemistry from the National Autonomous University of Mexico, where he won the Weizmann Prize from the Mexican Academy of Sciences for the best doctoral thesis the year he graduated. Then he did postdoc research at Columbia and at Rockefeller as a Latin American Pew Fellow. Then he went to spend about a decade at PLoS Biology as a senior editor and team manager. At the time, I think PLoS was really on the cutting edge of open access, open science, open publishing. And then has transitioned more recently to head of outreach at protocols.io. I don't know if any of you saw my little note in my email. I've actually been using protocols.io for a really long time now, since I got trained when I was working with the Moore Foundation Experimental Model Systems project. It's really useful. We keep our lab protocols on there. I have recently used it to make it easy to publish protocols in a paper. And I think there's probably a lot of things I don't know about the platform that I'm going to learn today. So,
thank you so much, Jackie, for the generous introduction. Thank you very much for hosting me and to give me the opportunity to talk about the power of sharing detailed methods and about how we hope that you see an opportunity for earning credit, preserve your work, and enhance reproducibility both inside and outside your lab. The presentation is going to be a mixture of slides, mostly, but I'm also going to do some live demos in the platform itself. And I have divided the presentation in two big sections. So in the first part, we're going to talk about the importance and the benefits of openly sharing our detailed research methods. And in the second part, from point 3 to the end, is going to be protocols.io as a tool for you to practice open science when it comes to methods. It's going to be a lot of information. The presentation is being recorded, I'm told, and I'm going to share the slides with the participants or the organizers, and they are free to distribute them as widely as they can as a resource in case you need to revisit. But I won't be able to tell you everything about protocols.io. So at the end of my presentation, I'm going to share some resources about how to get help if you want more training. But let's begin with protocols.io's mission. So what is protocols.io? So protocols.io is, on one hand, a digital platform for the collaborative development and sharing of detailed research methods. And on the other hand, it's an open access repository for the publication of these experimental protocols. In the open access side, it is free to create an account, and it is free to publish an unlimited number of protocols. Because all these protocols are published with a CC BY license. That means these are open access, so it's equally free to come, read, use, and reuse any of the public protocols. And to give you a context of why our founders creating protocols.io, we like to use this tweet. This is in the field of physics, but we have a scientist trying to understand how certain devices that are reported in a paper from 2017 were fabricated. And what he hits is a chain of citations that take him to the original publication of 2009, which simply says in the materials and methods section, devices were fabricated with conventional methods. And probably you have all faced like a similar situation. And this highlights just how difficult it is sometimes to reproduce published work. I know this is not your field, but a part of the background on why protocols.io was created, we like to talk about the Cancer Biology Reproducibility Project, which was a $1.5 million initiative coordinated by the Center for Open Science and by Science Exchange. And the goal was to take about 200 experiments from 50 high-profile papers in cancer biology and reproduce those experiments. That's it. And what you see on the screen is the website of the Center for Open Science that summarizes some of the results of this project, $1.5 million. And what they discovered very soon is that it is very difficult to reproduce any of these reported experiments. There are many reasons why that is difficult, but one of them is that in the 193 experiments that they tried to replicate from 53 articles, 0% of the protocols were described with sufficient detail for the researchers to reproduce, 0%. And equally striking, when the researchers hired by the reproducibility project contacted the original authors to get those detailed protocols, they discovered that those didn't exist in many cases or couldn't be found. So the problem of lack of reproducibility goes beyond the lack of adequate reporting in published articles, but also highlights deficiencies in the way that all scientists keep records of our own experiments for housekeeping. And that goes against the value that researchers put on methods. So what you see here, it's research published in PLoS Biology, PLoS One, asking scientists what is the importance of different article sections. And what you see in pink, hopefully, is that as the career of scientists progress, the value of the method section increases. However, we are incapable of storing and reporting those methods. Therefore, we thought that a cloud-based system for the development, preservation, sharing, and publication of detailed research method was needed. So as I mentioned before, generally speaking, protocols.io comes in two flavors. So we have the open access repository, which is completely free to use. Anyone for free can create an account and publish an unlimited number of protocols, which will receive a digital object identifier, or DOI, making these protocols persistent and citable. Because these are published in an open access repository under a CC BY license, these protocols are also equally free to be read, used, and reused. But our business model relies on having premium accounts that offer everything the free plan offers, plus an unlimited private space for collaboration and protocol development. And I don't want to delve here too much, but if you are interested, you can learn more about our academic plans at protocols.io/plans/academia. And I will talk about what these workspaces are that I mentioned, and I forgot to say that the institutional plans also come with a free import service, which I will touch also at the end. But protocols.io started in 2014, and we currently have, as of October 18th, more than 165,000 registered users who have created over 15,000 public protocols and over 55,000 private protocols. And in 2022, over 2 million people came to the platform to read these public protocols. But I want, before I tell you more about protocols.io, I want us to discuss why it is rewarding to publish detailed methods. And the key message that I want to convey here is that sharing your detailed experimental methods doesn't only help the readers, your community, but also benefits yourself, the practitioner of open science. Can you hear me well, right? So, but the first step is to show you how the protocols created in the platform and open and published in the open access repository go far beyond what a traditional static PDF offers. the protocols created in protocols.io are dynamic, interactive, versionable, forkable, live documents. So I'm going to open one of these protocols, which is a protocol that describes, it's a document that describes a protocol for measuring dissolved black carbon in water. Because this is a public protocol, it has received a DOI, again, making it persistent and citable. The protocol itself is written in a recipe-like step-by-step format. Different sections of the protocol can be coded in different colors, creating a table of content that I can navigate. As you can see, the protocols can be enriched or supplemented with pictures, images, tables, videos to clarify potentially, difficult steps. This is an interactive document because any reader can come, being this a public document, and post a comment, and the authors will be notified. And I will show you a little bit more about this functionality later on. The protocols are versionable, and I can navigate between the two different versions of the protocol. Any reader can come and create their own editable fork or copy to improve or optimize this protocol according to their own needs. So any public protocol is actually a template for further optimization. And if this were a protocol for a bench experiment, this can be run directly from the computer or tablet. It's working, but as I make progress in my experiment, I can tick off every step as done. And you can see the progress of the experiment here. Let's say that I noticed something unusual or I made a mistake in the run of my protocol. I can add a comment, which is not typing. I can add an image if unexpected result, the picture of my gel or whatever, post it, and then I can save the record of that run as an independent file. So in a way, it works. I can create a timestamp, and it works as a lab book in a way. But let's go back to the presentation. And, there you go. Okay. And even though there is a historical bias for protocols in wet biomedicine, actually the platform is agnostic to the area of research. And researchers in many fields have started creating and publishing protocols beyond the classical molecular lab. So I'm only putting here 3 examples, but these are protocols created and published in the platform in archaeology, computational biology, and clinical research. And just as an example, if I open the protocol in computational biology, again, you can see it has a DOI, and you can follow the protocol, step by step with images, recipes, pictures, hyperlinks to GitHub, and entries for code and data set, etc. But what about the motivations to make these protocols and to share them? And not necessarily in order of importance, but a first advantage of creating and sharing your protocols is that you increase their discoverability and reuse, which should lead to more credit and recognition. So, and if you're not familiar with this concept, I would like, before I share more details about the concept of modular communication of research outputs. So in this cartoon at the center, it's the peer-reviewed paper. So this is the bread and butter. This is the currency that you will eventually put, or you are putting on your CVs and that your employers and promotion committees will count and assess to grant you grants or promotions or to hire you. But around this paper, we start more and more seeing researchers sharing other outputs of research as independent modules. And then we have code and we have data that we go and deposit in specialized repositories like GitHub for Code, or Open Science Framework, Dryad, Fixture for data, and methods are another module of research that are catching up with this modular sharing. And that's why we created protocols.io to be able to share your methods as an independent module of research, are hoping to pave the way for which researchers receive credit. But so how does that increases discoverability? How having modules increase their discoverability and reach? So I'm going to use Twitter, now called X, as another example. So we have here a scientist in Chile that is tweeting, trying or asking the community for a protocol for RNA extraction from primary cortical neurons in culture. Somebody responded that tweet and recommended a protocol that has been deposited in protocols.io. But that protocol was actually part of a paper published in the journal GigaScience. But this paper is about a fish parasite. So the chances of researchers working on primary cortical neurons in culture finding a paper on a fish parasite as a means of finding a protocol that will work for them seamlessly. But because the protocol was published independently in a specialized repository, made this protocol more discoverable and increased the chances of people working beyond the fish parasite field of using it. And once the protocol is published, the document has a tab that is called metrics that reports in real time the number of views, exports, copies, bookmarks, and citations that the protocol has received. Another advantage of documenting and publishing your detailed methods is preservation. And as we know that a large proportion of the lab personnel at any given moment is floating, students graduate and leave, postdoctoral researchers become faculty elsewhere, and so on. And traditional paper lab books are easily misplaced, damaged, and lost. So by creating your protocols in a cloud-based repository and publishing them helps preservation. And I have to say that everything that is created and published in the platform is backed up and mirrored in CLOCKS, GitHub, and the Internet Archive. So they will stay live forever. Another advantage is collaboration. As we have seen researchers reporting that by sharing their protocols independently of research articles, increases the chances of establishing collaborations. And I mentioned briefly the common functionality of the platform. I want to show you an example of how this could potentially lead to collaboration. So we're seeing here, again, a public protocol that is very, very popular. And you can see on the tab up here that this specific protocol has received over 1,200 comments. Again, any reader, being this an open document, can come and read the conversation between users of the protocol and the authors. The conversation, again, the user can upload an image and say, like, why am I getting this pig? And, the authors respond. And you can see how this open scholarly communication could potentially lead to collaborations. And another benefit of creating and publishing protocols is streamline your publishing pipeline. Again, using Twitter, we have here a faculty at WashU in San Luis saying, what would happen, or like, why if lab publish each of their unique methods and protocols, he says in bioRxiv, but in future papers, instead of rewriting the protocols, we just cite these published methods. We waste so much time on methods by saying the same thing differently. And that is exactly what protocols.io is about. So you can create your detailed methods, publish them, get DOIs, and both you and your colleagues had cite these DOIs over and over again without the need to rewriting vague method sections. And this is what the authors of this PLoS biology paper did. So they created, deposited, and published their protocols in protocols.io, obtaining a citable DOI, which they included in the materials and methods section. Now, the reader, and that can replace actually most of the writing. Now, the reader has access to the detailed protocol in protocols.io by following the link. Now, one really nice thing about how protocols.io works is that, as I mentioned before, the protocols are versionable. So if a new version has been created since the time of publication, the reader will be notified. And they can choose to read the protocol as it was published at the time of publication of the research article, which is now highlighted in gray, or by following the view the newer version link, have access to the optimized version of this same protocol. And finally, or not finally, but another advantage is that by creating, preserving, and publishing your protocol, you will be compliant with both NIH and NFL, NSF guidelines that establish, as of January of 2023, all competing NIH application for grants must provide data management and sharing plans, and methods are an integral part of data. And the NIH rigor and reproducibility policy establishes that applicants need to describe details, and these details should be assessed by the reviewers. And the NSF establishes that open access platform or repositories comprise the most efficient way to publish and share research data, and methods, as I mentioned before, are an integral part of data, because I venture to say it is hard, if not impossible, to interpret data if you don't understand how these were acquired, and that's methods. And finally, as a bonus for practicing open science, you will be increasing reproducibility in the field, which you can see as a gift from you to your colleagues, but also reproducibility within your lab, which you can see as a gift to yourself. Oops. And in a push to increase accountability, transparency, and reproducibility, several organizations, including over 500 scientific journals, funders, and institutions in 3 continents support and encourage the use of protocols.io. And I have to say that regarding to journals, the way that protocols.io understand publication is different from the way journals understand publication. For us, publication is deposition in an open access repository akin to what bioRxiv is for full papers, whereas for journals, publishing is the result of peer review. The protocols in protocols.io are not peer reviewed, and the journals don't see a conflict on the position. Not only they don't see a conflict with the position of protocols, they encourage you to share your methods, and because that will increase reproducibility of the papers that they publish. And now, I hope that I have persuaded you, even if a little bit, of the importance of practicing open science and the benefits to you as a practitioner. But now let's discuss, or let's talk about protocols.io. So for those who are not familiar, the architecture comprises 3 main sections. So we have the workspaces, which I briefly mentioned before, the file manager, and the editor. So I will use a very simple cartoon to explain what they are. So the workspace is where everything happens in protocols.io. So it is from this space that you create protocols and collaborate with others. The workspace has a folder that will contain this protocol and is organized by the file manager. And in the file manager, you can use the editor to create these detailed recipe-like step-by-step protocols. Now, this is the welcome page. So if you go to protocols.io welcome, this is what you will see. You can sign up if you don't have an account and start your first session. You can also create or log in using SSO or ORCID, Facebook or Google. And the first step, once you enter the system, is to create your workspace, which in this example, I entitled Research Project 1. The platform will also ask if you want to invite anyone to join this workspace, but this is not a compulsory step. But if you decide it could be another student or postdoc, a faculty of the same institution, or beyond that, and once you enter the system, you have created your workspace, you have access to the file manager, which in this case is empty because the workspace is new. To the right, you have access to the administrator menu of the workspace, and to create a new protocol, you go to the new button. The file manager will eventually contain, display, and organize all the protocols that you have created within that workspace, which is this collaborative space. The file manager supports any file type, so you can create editor protocols using the editor, but you can also bring PDF, Word documents, Excel spreadsheets. It supports archiving, auditing, and exporting, connecting to Dropbox, OneDrive, Box, Google Drive, and so on. And it has been designed with enterprise-grade security, and as I mentioned before, backup functionality. So everything that you bring to the platform will be preserved and protected. What you see now is a view of the editor. It has detailed components to specify components in the editor. It has a granular editing history that shows you all changes to the protocol and allows any of these to be reverted if that is needed. The same as a Google document, the editor allows concurrent editing by 2 or more collaborators working simultaneously on developing a protocol. The protocol is written in a step-by-step format, and different sections of the protocol can be coded in different colors to ease readability. So now going back to the workspace, this is the space for collaboration. So you can invite anyone to join your workspace. This can be students in your group, other postdocs, another faculty within or beyond your current institution. To invite people to your workspace, just to orient ourselves, this is actually my profile, and you can see that I belong to many workspaces. Each of them has a file manager that will organize the document in that workspace. So to invite people to the workspace, you go to the administration menu, you select manage members, and now you can invite people by typing their email address. To join your workspace, they will have to create an account in protocols.io, but as I mentioned before, this is completely free. You can make your workspace public, which means it will be searchable and people can request to join. Or you can make it completely private, which is the default setting. And you can also customize what the members of your workspace can do, such as inviting other members or deleting or sharing files from the file manager. So this is all. Membership is very customizable. Members of a workspace will have access to the documents that you have stored in the file manager and make comments on those documents using the comment functionality that I showed you before, or they can ask questions. They can also make changes to the protocols that you are sharing with them. And as I mentioned before, there's a detailed log of all implemented changes, which can be reverted if needed. So it's very easy to collaboratively develop protocols. A member of a workspace can also create their own protocols and store them in that file manager, or they can take an existing protocol, make a fork or editable copy, and optimize it according to their own needs. So let's say that you work on a single biological problem, but you use 2 different species. You can develop, the former postdoc could have developed a protocol using one of those species. Anyone can take it and make the changes that are necessary to implement it in a different species. And the protocol allows you side-by-side comparison of 2 versions of the same protocol. So in this example, this protocol has 3 versions, and I'm going to be comparing version 1 to version 2, and the protocol and the platform automatically highlights the differences for you. So it's really easy to see what has changed from one version to another. And even if a member of your workspace leaves, let's say because a student has graduated, the protocols will remain organized, preserved in the file manager. You can also choose to export your protocols in case you want to have a hard copy of it at your bench while you're running experiments. In this case, I'm going to send a PDF to my computer. And this is a long protocol that has an abstract and an introduction and references and notes, but eventually I'll get to the step-by-step. So you can print this document and have a hard copy next to you. But as I showed you before, you can actually run the protocol from your computer, cell phone, or tablet and save a record of that run for that day. So I've talked about the workspace and how you can bring people into your workspace to collaborate on method development, but you can also collaborate beyond your workspace by sharing your protocols, specific protocols with specific people beyond your workspace, or by publishing them. So to share a protocol, I'm opening again my file manager. I can take a protocol and share it with people without bringing these people to my workspace. I can send this protocol to anybody just by typing their email. And once I add them as collaborators to this very specific document, I can control what they can do with that document. So 3 of my collaborators for this specific document are editors, and 1 is just a viewer. So you can tailor how much you can collaborate. So publishing a protocol will assign to it a DOI, making the protocol citable and searchable and persistent. And anyone with an internet connection can search for it and access it and read it. It will also create a log that will not allow further changes to the protocol. So a published protocol is not editable anymore. A published protocol with an assigned DOI becomes a citable object that can be referenced to in the reference list of a paper, and the reader will have access by following the link to the detailed step-by-step protocol, even if the paper was published behind a paywall, because everything we publish is open access. Once you publish a protocol, it becomes a template. And anyone with an internet connection can make a copy of the protocol and optimize it according to their own needs. But the platform has a memory that will create a line of credit for during the evolution of the protocol. Let me show you an example. So here we have a protocol that was published by somebody, but the platform tells us that this protocol was actually forked from a different protocol created by somebody else. And the reader, by following this link, has access to the original protocol. So the authors get credit for protocol creation and optimization, and the reader has access to the history and evolution of the protocol by following the fork link. And another way for getting credit goes beyond just publishing the protocol and getting a DOI. So Protocols.io recently established a collaboration with the journal PLoS One, the open access journal PLoS One, by which you can send to this journal your protocol for peer review and publication as an indexed paper. So PLoS One created this new article type called lab protocol. And when you submit a lab protocol, the editors and reviewers are not expecting results beyond those needed to validate the protocol. The protocol, the paper in PLoS One, which is to the left, your left, and the protocol will be bidirectionally linked, so you can access the protocol by following the protocol link, and the protocol in the platform will receive additional badges indicating that this protocol has been peer reviewed. And you know, in the materials and method, the link of the protocol is also provided. Now, going back to the workspaces, as I showed you very briefly before, you can create multiple workspaces depending on your research needs and your teaching needs. Every workspace can have different documents and protocols. You can place the same protocol in different workspaces, and every workspace can have different collaborators. So there's a lot of flexibility for you to organize how you work and collaborate. And you can, there's people that have been using protocols as well for teaching. So this is an example of a workshop run at North Carolina State University. This is a workshop for nanopore sequencing. And the organizers of the workspace, if you go to the application tab, you will see that all, no, not the application tab, sorry, the, what tab? Oh, resources, where are resources? Here. Now I'm lost. Go. Oh, I apologize. Oh. I can't find it. I can't find it. Resources here. So they have created the material for the workshop. This is a theoretical and practical workshop, and they have uploaded the protocols in Protocols.io for the students to follow. And as you can see, being these, interactive documents, the students can come, post comments, questions, and the creator, the teacher will be notified. And you can see how this feedback could lead to improvements in the protocol itself. So, and I don't know how are we doing with time. And I know that, I hope that you see some appeal in using the platform, but you might be wondering, well, I already have all these protocols already created as a PDF or Word document. I use Google Drive. This is too much work. So I just want to run a short demo on how you can bring existing protocols to the platform. So I'm going to minimize this, go back to my file manager. I created a folder for this demo. So the easiest way for you to bring protocols into the platform is just take them from your hard drive and drag them to the platform. Very easy. And your protocols will be stored as PDFs or Word documents in this, and you are centralizing everything protocols related in a single platform. Now, you can share those protocols from the platform, but because these are not protocols in the technical sense, these are PDF or Word documents, they are not publishable. So you can store them, you can share them, but you cannot publish from the platform a protocol in a PDF form. There is a workaround, which is to create, using the editor, an empty protocol So I'm creating a protocol now with the editor. I can add a title. I can add an abstract, and that will make my protocol more discoverable. So if people in Google or in the search engine of the platform type a keyword in the title or the abstract, your protocol will be more discoverable. The search engine doesn't look at the PDF if you created your protocol as a PDF, but it will be looking at the title and the abstract. And then in the description tab at the bottom, there is a window where you can drop your PDF. So the protocol will still be a PDF, but now the document is a protocol that is publishable. And because it has a title and an abstract, it will be searchable. And now you can assign a DOI to that PDF by making it the attachment of a protocol. Now, the third way is to, if you have a text file, you can actually import the steps. Obviously, you can type the step one by one by clicking here, but you can also insert steps from a text file. And this is what I want to show you how to do it. So you click here, a window opens, and if you have a protocol as a text file, in this case is a Google sheet, I can copy my steps where I was, here, paste them here, and now the steps in the text document have become steps in my protocol. If I go to the viewer, now I can see the steps here, and now I have an interactive, dynamic document that accepts comments, can be run from the computer and tablet. So this is the demo that I want to show you. That is not that difficult to create protocols in the platform if you already have a protocol in a text file. It could be a Word document, a simple text file, a Pages document from Apple, or a Google document. So you can drag and drop your documents, you can attach them to a protocol, and this will make them publishable, or you can import the steps from a text file to create a dynamic, interactive, versionable, publishable document. And finally, we offer an import service. So we have a team of editors, and you can send us, by going to protocols.io/we-enter-protocols, your protocols in any format, and our editors will typeset them to this interactive, dynamic format, but this service has a cost. But you can do it yourself as well. And so I hope that I have persuaded you to that protocols.io and in general practicing open science will help you stay organized, collaborate efficiently, save time, increase your impact, and get credit. I know that I said a lot, and I hope that I piqued your interest. We have further resources for training. So if you go to protocols.io webinar, there you will see a list of webinars covering different topics and organized to different time zones, and you can sign up for free. We also have one-to-one demos. So if you want to learn more, you can request freely one of these demos, and you will have the opportunity to talk to one of our specialists who will try to resolve any question that you might have about the platform. And with that, I will take any questions.
You already have the first hand up. Sorry if I missed it. How does your website rank search results? Like, how does it determine which protocol pops up?
Yes, we can actually do that. So let's say if I choose PCR. So you can search. Before I answer your question, in the search, you can search for publications, but you can also search for people that have used that keyword from workspaces. But once you have once you have searched for publication, it is by relevance. So title, abstract, steps. And then, but you can also select by date. You can rank them by date, title, and work for me. So if I rank them by work for me and I open the protocol, you will see that there is a button that says works for me. So people who have used this protocol can click it and it will increase to 13. If I click it again, it go back to 12. So there is no multiple clicking. And we don't have a doesn't work for me because we think that when a protocol doesn't work for me, many things could have gone wrong. So we want people to engage with the protocol and go to the step and saying, this step is not working for me. But yeah, so going back to your question, this is how we run them. Did I answer it?
Can you clarify, so if you publish a protocol and you get a DOI, right, you might need that for your publication manuscript that you're submitting, and then in the review process, you get feedback that requires editing that protocol. That published DOI is now, you said, not editable.
That's correct.
So how do you recommend the workflow? Like, is there an interim stage where there's a temporary DOI while it's going to be the review?
So there are two ways of doing it, and I offer them to you and you decide. So one way is you publish your protocol, you get a DOI, the reviewers comment on your protocol, and then you can create a new version of your protocol that will, in your edited manuscript, in your revised manuscript, you replace the old DOI with a new published version. So it will be V2 instead of V1. That's one way. The second way is that you share with the reviewers the private protocol, which is still editable. So again, if I go to my file manager, just as a code, private protocols are orange, public protocols are blue. So these are public protocols. But if I go to a private protocol that hasn't been published, it doesn't have a DOI, and I go to share, I can get a private link that I can share with the reviewers. And this link is view-only mode. So the reviewers will be able to view the protocol without making any changes. And then you can still edit this protocol because it hasn't been published. So there are two ways: versioning or sharing a private link of an editable, private, still editable protocol. Did I answer your question? If there is a middle way, so if I decide to publish this protocol, there is actually something that is called reserve a DOI. So you can get a DOI for that private protocol that will make your protocol uneditable, but it won't make it public. So if you work in a very competitive field and you don't want to share your protocol, but you want to get a DOI, you can reserve a DOI. If you have to make changes, you will have to create a new version. If there are no changes, you can proceed with publication, and the published protocol will receive the same DOI that you reserved. But if you reserve a DOI, the document is private, but not editable.
So have you gotten pushback from journals who've said, like, it's not enough to just have the DOI, we want the full protocol written out in the methods section?
Well, I don't publish, so
Yeah,
I don't
maybe
know
first.
if an author, but no, I think that usually journals restrict space, right? Like it is journals who say, like, you can't write more than 300 pages, 300 words. So they encourage it because while keeping the space short, you can actually have everything in the repository.
Questions?
I actually have one. So, do you have any idea whether people are starting to maybe put a new category in their CV with like list of published protocols? I'm thinking of doing that in my CV. I don't know.
Yeah, I mean, we hope that this becomes a way in which researchers get credit. We know that 60%, I mean, I'm going to try to answer your question by turning it around. We know that 60% of our traffic doesn't come from PubMed. So it's not through papers, it comes from Google. So people are using the protocols independently from the research articles. So they are usable, they're used tools that then I think deserve to be included in your CV. And I guess because there is a metric tab, you can actually tell how much traffic that protocol has received. It's not a single number, it's not an impact factor or something, it's more like a metrics because there's how many times people have bookmarked, how many runs your protocol has had, whether there has received citations. I have to say that the citations is limited because we only have access to the reference list in open access journals. So if your protocol was cited in a journal behind a paywall, we don't have a way to know, right? Or if it was cited, with a URL and not the DOI, we won't pick it up. So there are limitations to the number of citations that we provide in our metrics, but I think that it deserves, particularly if the protocol has been used. I mean, that indicates impact of your protocol in the field. I don't know if people are doing it, but we encourage that.
There are no more questions?
So let me say what I forgot to say at the beginning, right? So there's gonna be pizza,
Yes.
right? And during transitioning to after pizza, Dr. Gasque would love to meet with students or postdocs or anybody else who would like to talk about non-academic career paths in science. Please come join, have a conversation. At least starting by 2 and probably before, while you're eating.
I will leave the slides. Well, I will send them via email, and you are free to distribute them as much as you want. And that's my email address. So if you want to drop me an email also with a question or a comment, I'll welcome those.
Thank you.